Hi there, my name's Raz, and today we'll be looking at functions and the graphing of the modulus. So a little recap. So remember, the modulus function is simply a number where we're interested in the magnitude of the value and not the sign. So the modulus of x would be x. The modulus of minus x would also be x. So let's look at example 1. And we want to solve, and obviously draw, since this is the drawing of the function, this video. We want to solve the modulus of x minus 2 equals 3. So that means we could have plus or minus x minus 2 equal to 3. So if we take the positive, we would have x minus 2 equals 3, therefore x equals 5. And if we took the negative, we would have negative x plus 2 equals 3. So x would equal minus 1. So if we draw this, let's switch to white. First, we need to draw the graph of x minus 2. So the graph of x minus 2 would have a gradient of 1 and cross the y-axis at negative 2. So it looks something like that. Yeah, and we've got 3. So the graph of y equals 3 would look like this. Now, the only thing is we want the modulus of x minus 2, not x minus 2. So modulus is just means that y has to be positive. So this bit gets reflected through the x-axis. So what I've drawn, the V shape, is the graph of y equals the modulus of x minus 2. So the solutions of 5 and negative 1 indicate that point there and that point there. So when we're drawing the modulus of a graph, we reflect the part that goes beneath the x-axis through the x-axis. Yeah. Let's have a look at another one. Example 2. Sketch the graph of y equals 3x minus 2. So let's draw a nice axis there. Let me if that was yellow, let me get white. So 3x minus 2 has a gradient of 3, and we'll cross the y-axis at negative 2. So something like this. Yeah? So which part will reflect? Exactly, the bit under the x-axis. So that bit. So it's a sketch. It doesn't have to be perfect. And that'd be it. So y equals 3x minus 2 would be that. Maybe to make it just clear, I'll get rid of the white part of the line. And we've got that. So that is as simple as it is. That's what the modulus of a graph is. It is when y, if y is the modulus for x minus 2, y is always positive. So remember, y is the height of the graph, x is the width. So the height of the graph is always positive. So I think I have 5 examples. One, so example 3. So solve 2x minus 1 equals 5. So in this one, like we did in example 1, I have positive and negative 2x minus 1 equals 5. So if we take the positive version, 2x minus 1 equals 5. So 2x will equal 6, x will equal 3. And if we do the negative, we will have negative 2x plus 1 equals 5. So negative 2x equals 4, so x equals negative 2. Now we can draw the function. So I need the graph of 2x minus 1. So a gradient of 2 and a y-intercept of negative 1 will look something like that. I will reflect the graph to get the modulus. And I will yellow that part to make it clear. Oh, that wasn't clear. And then we need the graph of y equals 5, which will be somewhere like that. So the intersection points here and here would correspond to our solutions of 3 and negative 2. Yes, so from this question, we didn't have to draw the graph. Obviously, this video is about drawing the modulus function. So I'm just using these examples, these questions as opportunities to show you how to draw the modulus function. So the solutions would be 3 and negative 2, and that is what it represents. So essentially, this part of the graph is redundant. And the yellow one was modulus of 2x minus 1. And the pink part was y equals 5. Let's go to example 4. Solve 3x minus 5 equals 2 minus a half x. I'm going to draw this graph first. Just so I get the spacing of my page okay. So we want the graph of 3x minus 5. So a gradient of 3, a y-intercept of negative 5 will be something like that. I will reflect it here and yellow that part. So the white part of the graph is redundant. And then we want 2 minus half x. So that is a gradient of negative a half and a y-intercept of 2. So that might look something like this. It's a pretty terrible picture, but needs to be aware that that yellow line will have a y-intercept of 5. Because I didn't give myself much space for the green line to have a y-intercept of 2. Yeah, but we can see where the lines intersect and what the solutions will indicate. So now let's solve. So I have the positive and negative of 3x minus 5 equaling 2 minus a half x. So if we look at the positive first, 3x minus 5 equals 2 minus a half x. So plus the half x to 3x, so I get 4.5x. And 2 plus 5 is 7. So x will be 14 over 9. Oh, I did 3 plus a half is 4.5 for some reason. So let me just change that. 7 over 2x equals 7. X will equal 2. Now, if we do the negative solution, we have minus 3x plus 5 equals minus a half x plus 2. Yep, so we have 2.5x equals 3. So I'll move that there and move this here. So 5x equals 6, x equals 6 over 5, so 1.2. And those are solutions. So you can see that solution there is 1.2, and that solution there is 2. Hence why the graph was a little bit squashed. And let's go to the last one. It's solving into quantity 5x minus 1 is greater than 3x. So I'm going to draw the graph first again so I can space my page well. So 5x minus 1 has a gradient of 5 and a y-intercept of -1. So something like that. We can reflect that, like so. Yellow that bit out to make it clear. This bit becomes redundant. And then draw the graph of 3x. So it's just another y-intercept of 0 and it will cross somewhere. Now let's solve it. So plus or minus 5x minus 1 is greater than 3x. So let's take the positive root first. 5x minus 1 is bigger than 3x. So 2x is greater than 1. So x is greater than a half. And if we do the negative, we have minus 5x plus 1 is bigger than 3x, which means 8x is less than 1. X is less than 1/8. Yeah, which represents that part of the line there and that part of the line there. So I hope you found this video useful. I look forward to seeing you soon.